Hello everyone. So this video is going to go over the topic of input-output analysis, which will apply the matrix algebra that we've been learning so far. So to get started with understanding what input-output analysis is all about, let's think about a simple economy with just firms and households. And this may actually be familiar to you from a typical circular flow diagram that you would have seen in introductory economics courses. So the idea here is that the households, they supply labor to the firms, and the firms in turn, once they produce the output, that output is now being bought or consumed by these households. So this is a very simple framework for a circular economy. Now, the firms don't necessarily have to supply to the households only. They can also exchange goods and services between themselves. So they exchange goods and services between themselves as well as provide for external consumption by households. So can we think of a few examples where this may be possible? So we can think of something like the steel industry, right? So to produce steel, we're going to need iron ore, coal, and a few other things as inputs. And steel is now going to be produced as an output. But this output of steel can become an input into certain other commodities, such as engineering firms that produce machine tools and so on. They're going to use steel as an input. So the output of steel, so the firms are now exchanging, right? They're exchanging the goods and services between themselves. So steel is being exchanged with this engineering firm that produces machine tools. And in turn, the steel industry is going to be using some of the machine tools that the engineering firms are producing in order to produce steel. So you can see how there is this interrelationship and this flow of goods between industries. And in addition to doing that, steel, the output of steel that's produced is also going to service household consumption. And we can see households having utensils or something made of steel. So this is one scenario where we can see this flow, and you can even think of something similar in an agricultural context, where to produce food grains, land is an input, and then once the food grains are produced, the grains may probably become an input when you're thinking about producing animal feed. So the output here becomes an input somewhere else. And the output can actually become an input into itself too. So the food grains that are produced, a part of that can be saved as seeds, which now becomes an input into producing more food grains. And food grains will also definitely be set aside for household consumption. So an output that's being produced can be used as an input in its own production. It can become an input into the production of some other output, and it can also go and service household consumption. So let's put some names and terms to all of these different channels that I just described. So output that is destined for households or the final consumption is called final or external demand. An output that now becomes an input by another firm or by the same firm, think of the food grain example, right? That is then called an intermediate output. So if an output of one industry becomes an input either in its own production, or if it becomes an input in the production of some other industry, then we call it an intermediate output. Now, all of these terms are in the context of input-output analysis. Now, input-output analysis actually deals with the flow of these inputs between industries and amongst themselves, as well as between, the flow of goods and services between these firms. So that's what input-output analysis actually deals with. So it's the problem of identifying the different firms and goods, and then tracking down the flow of goods as well as tracking down the flow of money for these goods. That is called input-output analysis. And I will state a caveat here that input-output analysis is a really big field in itself. And in fact, the pioneer of input-output analysis, a scholar by the name of Leontief, actually won a Nobel for his work on this. So this is a huge field, what we're doing in this course is just a tiny snippet of an introduction to what the actual topic is all about. All right. So now let's look at an example and start conceptualizing how we bring in matrices into understanding and dealing with input analysis. Suppose there are two industries and we'll call them I1 and I2. Now to produce $1 worth of output of the first industry, let's say it's going to use as inputs 10 cents worth of its own output and 30 cents worth of the output from the other industry. So to produce 1 unit of output from the first industry, it's going to need 10 cents worth of inputs. To produce $1 worth of output, it's going to need 10 cents worth of its own inputs. Think about this as maybe the production of seeds. Not all food grains will become seeds. Only a fraction of food grains are now going to be recycled back as seeds. And then you're going to have other inputs which will be coming from other industries. So in this simple example, we're going to have 30 cents worth of input, which comes from I2. And similarly, to produce $1 worth of output of I2, it's going to use 50 cents worth of input from the first industry and 20 cents worth of input from its own production. Now, this is a little cumbersome to talk about when you just put it in words. A straightforward way to conceptualize this is to put it in the form of a table. Now, if we measure inputs in the rows and if we measure output in the columns, so let's say we have the output of industry 1 here, we have the output of industry 2 here, and these are the inputs that are flowing out of industry 1, inputs flowing out of industry 2. We'll read the rows that way. Okay. Now, let's and here the way to read the columns would be to produce I1. How much of inputs do you need from I1 and I2? And to produce I2, how much of inputs do you need from I1 and I2? Now, let's go over the columns and fill them up. To produce $1 worth of output of I1, we need 10 cents worth of I1. So to produce $1 of output, I need 10 cents worth of input of I1, and we need 30 cents worth of I2. And similarly, to produce $1 worth of I2, we're going to need 50 cents worth of I1, and we're going to need 20 cents worth of I2. And when you put this together in a table, it is neat. And when we want to start doing analysis with this using matrix algebra, the next natural step is to put this in the form of a matrix. So we can write this as 0.1, 0.5, 0.3, and 0.2. And this is actually called the matrix of technical coefficients or technology matrix. And as the term implies, the technology matrix actually describes the technological process required to produce $1 worth of I1, which is how you read the first column, and the technology needed to produce $1 worth of I2, which is how you would read the second column. Okay, so this is now the building block of the input-output analysis. Now, okay. In general, if there are n industries, okay, then the technology matrix is now going to be of the order n by n. You can see in this simple example, right? We just had 2 industries. Therefore, the technology matrix is of the order 2 by 2. And where does this 2 by 2 come from? Each input will have, each industry, right? It's going to bring in inputs from its own production, and it's going to get inputs from all the other industries that are there. So because there are only 2 industries, Each industry will now have inputs from itself and the other one. So they're going to be 2 by 2, 4 entries there in the technology matrix that we have. So when you have n industries, the order of the matrix then becomes n by n. And each element Aij is going to be the input that is needed from the ith industry to produce $1 worth of output for the jth industry. So here, if you want to read, if you want to think about this particular simple matrix that we saw earlier, if we think about A11, that is input needed from the first industry to produce $1 worth of output of the first industry. A12 is going to be input needed from the first industry to produce $1 worth of output for the second industry, which is what we had given in the description there. And similarly, A21 is input from second industry to produce $1 worth of output from the first industry, which is given by 30 cents here. And A22 is input from second industry to produce $1 worth of output for the second industry, which is 20 cents. So that's how you construct the technology matrix. Now, an important assumption that we typically make when we do input-output analysis is that the production functions for each industry that is in the model is assumed to exhibit constant returns to scale. What does that mean? Constant returns to scale actually tells you that if you are scaling up your inputs or scaling down your inputs by a particular proportion, then your output is also going to go up or go down by the same proportion. If you double the inputs, your output will double. If you triple the inputs, your output triples. If you reduce your inputs by half, your output also falls by half. So that's the meaning of constant returns to scale. So what does that allow us to do? Once you have this technology matrix which tells you how much of inputs are exchanging or flowing between the industries in order to produce $1 worth of output, if you have that, you can always just scale that up and compute the technology matrix given a certain level of output. So for instance, for $1 of industry one's output, if these are the inputs that you need, then to produce $500 worth of output, you're just going to have to multiply the first set of inputs by 500, and then you'll get the corresponding inputs to produce $500 worth of output. So this will just be 0.1 into 500, and this will just be 0.3 into 500. And similarly, in the case of I2, it's the inputs to produce $400 worth of output will just be 0.5 into 400, and then 0.2 into 400. And that then becomes 50, this will be what, 20, no, it will be 200. Yeah, this is going to be, what am I doing? Hold on. So 0.5, yeah, this will be 200, and then we have 1500, and this will be 150, and we have 80 here. Sorry. So this then becomes the technology matrix when you're producing this particular level of output. So just a second. Do I want to cover more material here? Okay. All right. So I'm going to stop this video here, and I'll continue in the next video.